Assalamualaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss today, it is the chemical properties of water. So before the start of the topic, you guys must know that the properties are mainly of two types. The number one type of the properties that we have, it is the physical properties, and the second one type for the water we have, it is the chemical properties. When we have a look on the physical properties, so these are basically the properties that we can measure, that we can see. For example, if we talk about the melting point, we talk about the boiling point, we talk about the density, we talk about the physical state, and what is the main electrical conductance of the water. All these are known as the physical properties. And the chemical properties means simple how strong is that compound and how do it react with the other substances or when it come in contact with the other compounds. This is known as basically the chemical properties. It basically relates to the reactivity of the substances. So here we have the water molecule. If we have a look on its structure, basically the central atom is oxygen and the two hydrogen atoms are attached along to it, and the oxygen atom is having two lone pairs, and there are basically two bone pairs present and two hydrogen atoms are attached, and the ratio of hydrogen to oxygen we have 2 ratio 1. So this is the simple formula for the water molecule. Now we will study about its chemical property. So the first one is the thermal stability of the water. Basically thermal stability of the water is that how do it react or behaves in the presence of heat. Basically, water, it is a thermally stable compound. Now, why we call it as a stable compound? Basically, the main thing it is having hydrogen bonding. The water molecules contain hydrogen bonding, and that bonding is strong, and it enables it to a polar compound as well. So that's why water is thermally stable, and it just only because of that 1% of its molecule just decomposes to its components. If we have a simple look on its chemical reaction, if we have two water molecules, 2H2O, and we provide the heat that is 2000 degrees Celsius, the products we gain it is the hydrogen gas and the oxygen gas. So this is the simple decomposition of the water molecule that takes place at 2000 degrees Celsius, and it just decomposes into its components hydrogen and oxygen. Here you can see that this is the water molecule as like this. When we provide heat to it, what happened? The water molecule just remain like this. This is always happening because it is a stable compound which is known as thermally stable compound. Next we have its reaction with the metals. Water molecules reacts with the metals, both the alkali metals and the alkaline earth metals, the group 1a elements and the group 2a elements. Group 1a elements are alkali metals and the 2a are known as alkaline earth metals. So when metal reacts with the water, it produces two types of compounds. The number one is metal hydroxide and the hydrogen gas. So let's have a look on the simple reaction. For example, we have the metal that is alkali metal Na plus. It reacts with the water molecule. The product we gain it is sodium hydroxide plus hydrogen gas. So here the sodium is present in the solid state. The water it will be present in the liquid state. Sodium hydroxide it will be present in the aqueous form, and the hydrogen will be present in the gas form. By rearranging or by balancing the equation, here we have two sodium atoms, so we will have 2 by putting over there 2. So this is a balanced chemical equation, and when any matter reacts with the water, it produces hydroxide or metal hydroxide along with the production of the hydrogen gas. This is the simple example. We have the potassium. It reacts with the water molecule and it produces potassium hydroxide plus hydrogen gas. So this is the simple reaction. When water reacts with the metal, it produces its respective hydroxide. Next, we have a reaction with the known metals. We have a lot of known metals around us. Likewise, here we have the reaction of sulfur plus oxygen. It produces sulfur dioxide. Here, the sulfur is a known metal, but here we will discuss its reaction with the water molecule. For example, it can react with the chlorine, it can react with the carbon, silicon, it can react with the sulfur. So let's have a look on its reaction with the sulfur. When you have a sulfur, it reacts with the water molecule. The product we gain, it is hydrogen sulfide gas. H2S plus sulfur dioxide. Two types of gases will be produced here. The sulfur will be present in the solid state. The water will be present in the liquid state. Hydrogen sulfide, it is a gas, and sulfur dioxide is also an gas. So by balancing the equation, we'll gain 3 sulfur and here putting the 2. Now this is called a balanced chemical equation. When non-metals reacts with the water, different types of products will be produced. Next we have its reaction with the carbon, silicon and sulfur again. First one, we have a carbon. It reacts with the water molecule. The product we gain, it is carbon monoxide plus hydrogen gas. Now the product which is carbon monoxide and hydrogen, it is known as the water gas. This is known as water gas, and this is an important question that may be asked in the exams, that what is the formation of the water gas and how we can form the water gas. A simple reaction of the carbon with the water. Next reaction of the silicon with the water. The product we gain is silicon dioxide plus production of the hydrogen gas. So this is the simple reaction with the silicon and the sulfur. We have already taught sulfur plus water molecule produces hydrogen sulfide gas plus sulfur dioxide, and by balancing this we gain that. This is the simple reaction that just happened when it reacts with the known metals in any situation. So this was all about today's lecture. I hope you guys understand. And the next topic that we will discuss, it is the chemical properties of the water too. That how does it reacts with the metallic oxides? How does it reacts with the non-metallic oxides? So we will discuss it in the next detail. For that time, you guys keep learning and have a good day.